So synthetic division is long division without the madness that comes with long division. So this is very simple, very straightforward. You don't need to write many things. You just need to do simple multiplication and additions. That's all you have to do. Multiply and add. But before we do that, let's go back to the question. So there's a key number you must first find before you start your synthetic division. Firstly, you cannot use synthetic division unless the denominator, the divisor, is a linear expression. Okay? It has to be a linear polynomial. We need to find what the zero of this denominator will be. So x minus 2, you can quickly write it somewhere here and say x minus 2 equals 0. That means x equals 2. So you need this 2 essentially to start your synthetic division. And this is how you lay out the table. Let's do that. So this is going to be, just do this. Hide the 2 somewhere here because it's going to be dividing. But instead of you putting a line over here, don't put any line. Just write all the coefficients of the terms. There are 4 terms here. 1, 2, 3, 4. So the coefficient here is 1. The coefficient here is negative 4. The coefficient here is positive 3. The coefficient here is 2. And these are the terms that you'll be dividing with this. But this is how you do the division. You're going to leave a space because you're going to write numbers here. Just one space for a number set. And then you write your answers here. It's very straightforward. You only need 1 line, 2 lines, and a 3rd line of numbers, and you'll be done. It's quick, and it gives you 2 answers. It gives you both what the quotient would be. It also provides you with what the remainder will be. That's why it is everybody's favorite once you know how to do it. And this is what you do. So what you do first is you assume that there's a 0 here. It's an assumption you make because there's always a 0 there. You're going to see it at the end when I explain. So if you add 1 to 0, you're going to get 1. But we just don't want to write 0. Okay? Now, we move on. To move on, whatever answer you get under this line, you must take each answer and multiply it by whatever is here. So 1 multiplied by 2 is going to give you 2. So I'm going to write that answer I got here. For you to move on, take the answer to multiply this divisor. So 1 times 2 gives you 2. Write the 2 here. You just add. Remember I said multiply and add. You multiply, write the answer here, and add this. So negative 4 plus 2 is going to be negative 2. We move on. This is another answer. Take this negative 2, multiply it by 2. You're going to get negative 4. Write your answer in the next column. So we get negative 4. Okay, 3 plus negative 4 is negative 1. Take this answer, multiply it by 2 again. That's negative 2. Write it here. Add these 2 together, you get 0. The very last thing you write is the remainder. Always the remainder. So this is the remainder. I'm going to label this as the remainder. Okay, so that's the remainder of this function. Now, what does this mean? This simply means that when you divide this polynomial by this polynomial, you're going to get a quotient. Okay, the quotient is definitely, because you've divided x cubed by x, you're going to have x squared. So this term is going to be just 1 term lower than this term. So your answer here is going to be 1x squared. Okay, I'm just going to write the 1 so you get it. It's going to be 1x squared, then minus 2. Minus 2, because this is x squared, the next one is going to be just x. And then we're going to go to minus 1. That's it. So you just need to reduce the powers that you have here. So this x cubed becomes x squared becomes x, and x becomes no x. And this is already gone. That's how synthetic division is. So when you divide this by this, this is what you get as your answer. So we can easily write this as our answer. It's going to be x squared minus 2x minus 1. That's your answer. There will be no remainder because your remainder is 0. We'll take another example and see how that works out. Okay? Let's take another example. So let us say this is the polynomial that you have, and you're supposed to divide this polynomial by, let's do this, divided by, say, x minus 1. Okay? So instead of writing it that way, I'm just writing it this way because they could ask you to divide it whichever way. Now, I chose this question because I want to go to the next point that I want to make, which has to do with the factor theorem. I'm going to talk about that later. Okay. Now, x cubed plus 5x squared plus 3x minus 9 divided by x minus 1. Let's go ahead and find the 0 of the denominator. If we equate x minus 1, you say x minus 1 equals 0. That's going to leave you with x equals 1. So what you want to divide with is 1. So I'm going to write 1 and put it in a box. And the next task is to write all the coefficients of what you want to divide. So I'm going to write 1, and then positive 5, and then positive 3, and then negative 9. Okay, so the next thing to do is leave one space like this. And then we're going to bring this down. Remember, we always do that. You bring this down, and this is going to be, you assume there's a 0 here, and this is going to be 1. So you multiply 1 times 1, you get 1. You write the answer here. So we add 5 plus 1 is going to be 6. So we multiply 6 by 1, we get 6. And you write the answer here. And then you add 3 to 6, you get 9. Now you multiply 9 times 1, you get 9. And you get 9, and that's going to be 9. When you add negative 9 to 9, you get 0. So we get another situation where there is no remainder. So remember, when you divide a number by a number and there's no remainder, it means that this is a factor of this. It's like dividing 8 by 2. If there's no remainder, it means 2 is a factor of 8. So if they ask you to factor this, you know that at least x minus 1 is one of the factors you will get in your answer. So basically this is what we have. And remember, we said if the leading term here was x cubed, then the leading term in the answer for the quotient will be x squared, just 1 degree lower. So the actual answer here will be that there is no remainder. So this polynomial can be written as x squared plus 6x plus 9 multiplied by this. This is the quotient, and this is what you divided it by. So you can actually, is like writing this. Let me show you quickly here. If you say 8 divided by 4 and your answer is 2, you can conclude that 8 is equal to 2 multiplied by 4. So if you divide this by this and you get this as your answer, you can conclude that this equals this times this. That's how that works. So now look at what this question actually tells us. I'm going to erase this. So it means we can say that x cubed plus 5x squared plus 3x minus 9 is equal to this, which is x squared plus 6x plus 9 multiplied by x minus 1. That's the meaning, just the same analogy. So if a question tells you to factor, see, I'm going to take this out. So if a question says, what are the factors of this? Well, you already know that x minus 1 is a factor because we just did the synthetic division with it and it gave us no remainder. It confirms that this is a factor. Is there a way we can factor this? Yes, definitely. This is a perfect square. Remember, if you factor, what two numbers will you multiply to get 9? But when you add them, you get 6. It's 3 and 3. So we can just factor this and say this is actually x plus 3, x plus 3, and x minus 1. Which gives us, see, that's your answer. If you break this down, you're going to get this. You see how synthetic division helped us because we used x equals 1. Are you saying that we could have used one of these, x plus 3, also to divide and we'll get an answer? Yes, that's what I'm saying. And that's what we want to quickly try. So let's assume we want to try and divide this, okay, by x plus 3. I'm going to erase this side now and make this the question. Let's say you want to divide this by x plus 3, okay? What will be our quotient and what will be the remainder? Because this is a factor, we expect the remainder to be 0, okay? Because this is a factor, we expect the remainder to be 0, okay? So I'm going to erase this and then we're going to try and divide with this and see what synthetic division will give us. So let's erase this. Remember, we expect our answer to be these two together. Let's combine these two. That's going to be x squared plus 2x minus 3. That's what our answer should be when you combine these two. Okay? Let's see if that's what we're going to get at the end of it. I'm just going to write it in one corner here. X squared plus 2x minus 3 should be our final answer in the quotient and no remainder. So let's do that. So we're still going to do synthetic division. So we'll be dividing by, the 0 of this has to be negative 3. So that negative 3 plus 3 will give us 0. So we're going to use that. We have negative 3. And then the numbers we're using are 1, 5, 3, negative 9. 1, 5, 3, negative 9. Okay. Let's create the space. We drop this down. We have 1. Remember, we always do that. So 1 multiplied by negative 3 is going to be negative 3. So we write the answer here. And we add. 5 plus negative 3 is positive 2. Then we move on. So we go negative, so we have 2 multiplied by negative 3, it has to be negative 6. So negative 6. So 3 plus negative 6 has to be negative 3. So negative 3 times negative 3 has to be positive 9. So we have 9. When you add these two, you get a remainder of 0. And this is the quotient. The quotient will now be x squared, 1x squared, plus 2x minus 3. That's what we're supposed to get. X squared plus 2x minus 3. So synthetic division is super fast and helpful, especially when you have to find the factors of a polynomial. Why do you need the factors of a polynomial? If anyone ever tells you someday to draw the graph of this and you don't have time to plot figures, you don't have a computer, these are the things you need. You need the factors. Because if you know the factors, you know the point where it crosses the x-axis, at least you've solved almost half of your problem. Okay, so you need these so you can find the zeros. That's why we call them the zeros of the polynomial. Okay, there's one more aspect that I need to tell you. It is called the Rational Factor Theorem. Let's do it. So to explain the Rational Factor Theorem, it's good for me to start with a very easy example, okay? This is going to be short, but you need to really think, okay? I'll take this example and another example and maybe a third example so you'll understand the concept behind it. So the factor theorem means, this is easy, okay? Because you can actually ask yourself, what two numbers will I multiply to get positive 1? But when I add the numbers together, I'll get negative 2. Well, I know those numbers are negative 1 and negative 1. So that you can easily factor this and your answer will be x minus 1, x minus 1. Actually, these are the factors of this quadratic function. Okay. Now, but polynomials get more complex than this, and you can't easily just think and guess numbers and put them in, okay? But I'm going to apply the rational factor theorem to this number without using the factoring rule that I just used now. I'm just going to make us ask some questions. So the answer to this question is, you see, you have to consider the very last term. Remember, I'm talking about the rational factor theorem. See, the word rational gives you an impression. So you should know this generally in algebra, that the term rational means fraction. Okay, fractional. So you expect it to have fractions in what you're doing. Okay, but this is an easy example because this is what the fraction will look like. It will be this number, the constant term, no matter how long the polynomial is, if there is a term that contains no variable, that's a constant term, you take that constant term, in this case, it is positive 1. Okay? And then you divide it by the leading coefficient. I explained that in the first video. The leading coefficient is the coefficient beside the defining term. The defining term is the term that has the highest degree in the polynomial. In this case, it is x squared. Okay, so the coefficient of this is 1, so you divide it by, so let's just take the number itself, just the number, 1 divided by 1. So the factors, listen, the factors of this polynomial will include at least one of these, whether it is positive over positive, or positive 1 over negative 1, or negative 1 over negative 1, or negative 1 over it doesn't matter. Just play around with the signs. Whatever answer you get will be one of the factors. If it is not, it means it cannot be factored. Okay, it simply means that the factors that you can use to factorize a polynomial are basically obtained by this. It has to be one of these answers you get. For example, this answer is going to be 1. This answer is going to be negative 1. This has to be 1. And this has to be negative 1. So you're either using 1 or negative 1. Okay, so this is where synthetic division is going to help you, because now you have an idea of what numbers to use. You either use 1 or negative 1. You know what? Instead of factoring, I'm going to use synthetic division for this and see what I get. Okay, so I'm going to assume now that I'm using x equals 1. Okay, which will mean that x minus 1 is what I'm using to divide this. So I'm going to assume x equals 1 and use synthetic division. So let's go. This is going to be this, and this is 1, negative 2, and 1. Synthetic division, here we come. And this is 1. 1 times 1 gives us 1, and we put 1 here. If we add these two together, you get negative 1. Negative 1 times 1 gives us negative 1. You put it here, and your answer is going to be 0. So you're ending up with no remainder, which means this is a factor. Okay? So if this is a factor, what you have here will be 1x. Remember, the highest was squared, so the answer here has to be 1 degree lower. So you have, your answer is going to be x squared minus 2x plus 1 will be equal to, the answers here will be x minus 1 multiplied by, what did you divide by? X minus 1. That's it, which is the same answer we got from the other quadratic reasoning. Okay, one more example. So this will be the very last question I'm going to use, and I'm going to explain this theorem quickly again. So you can see that I have 4 here as the very last term, the constant term, and what I have here is 2, which is the leading coefficient. So what's going to happen is I'll try and figure out the factors that I could use. So there will be all the numbers that will divide 4, which will be 1, 2, 4. Those are the only 3 options I have, divided by the options of numbers that will divide 2 will be just 1 and 2. So what I do is, all the fractions I can get, that's the meaning of rational. Okay, it has to be a fraction. Okay, it has to be 1 over 1, or 1 over 2. Those are the two options I have with this. With this, it has to be 2 over 1 or 2 over 2. And it has to be 4 over 1 or 4 over 2. So some of these are duplicated. As you can see, 4 over 2 is the same thing as 2 over 1. So we just have one option. 2 over 1 is 2. So we just have 2 as an option, positive or negative. Either of those will work. So we're done with these two. 2 over 2 is the same thing as 1 over 1. So we just have 1 as the answer there, plus or minus. So these two also are good. Then we have 1 over 2 and we have 4 over 1. So those are the options we have. We have 8 options of plus or minus half, or plus or minus 1, or this or this. So we're going to try any of those. Okay, it's always good to start with the easiest one. Okay, you want to start with the easiest one. It's always cool to do that. So what I'm going to do is, and what do you do with them? You just check to see if any of these numbers will be a 0 of this polynomial. Because if any number gives you a 0, then it simply means it's a factor. So x minus that number is a factor. So let's try. The easiest one is 1. And I can tell you, anytime you try 1, you don't need to do a lot of work. All you have to do is just look at the coefficients and deal with them just the way they are. If you plug in 1 in any of these cases, you're going to have 2 times 1. So nothing changes. You try it. So it's going to be 2 minus 7 minus 5. That's negative 10. Plus 4. That's negative 6. That doesn't leave you with a remainder of 0. So 1 will not work. Now let's try negative 1. See, we've tried 1. Let's try negative 1. For negative 1, it's going to be, if you put negative 1 here, it's going to be negative 1. So if the power is odd, the negative sign remains. So this is going to make this negative 2. Now, because the power is even, the negative sign disappears, so which retains this negative 7. If you put it here to the negative 1, because the power is odd, it's 1. So it's going to be negative times negative gives you positive 5, and you have 4. Well, this is 0. This is negative 9 plus 9. So it looks like negative 1 was a good option. Okay, so we just tried negative 1. It's a good option. So it means x equals negative 1, or you can say x minus 1, sorry, x plus 1 is a factor. Okay? So remember, when you move this over, it's going to be x plus 1. So this is what we're going to now use to divide this and see what the other ones, what the quotients will be, so we know what all the factors are. So let's do that. And how will we do it? Synthetic division. You see, we've used the remainder theorem with x equals negative 1 to test that it's actually a factor. So now that we know we're going to get a remainder of 0, we need to know what the quotient will be so we can factor that too. So let's quickly go down to the synthetic division avenue and see what we can do with that. Okay, so we're going to use x. So let's write this in a corner because we know that x equals negative 1 checked out, which means x minus x plus 1 is a factor. Okay, we don't need all of these anymore. Oh, let's just leave that. So let's do synthetic division with x equals negative 1. So x equals negative 1. I'm going to bring down all these numbers, which are 2, negative 7, negative 5, and 4. Draw a line, bring this down. 2 times negative 1 is going to be negative 2. So this gives us negative 9. Negative 9 times this gives us positive 9. If you add these two together, you're going to get 4. 4 times this is going to be negative 4. And this is going to be 0. Okay, so that's going to be 0. And that's a remainder, but it has produced a quotient which is going to be 1 power less than x cubed. So it's going to be x squared minus 9x plus 4. That's what we have. So this is one factor of the polynomial. This is another factor of the polynomial. So, but we don't know exactly how this is going to be. We can use our quadratic knowledge, okay, to break this down. You can actually factor this, or you can still do synthetic division using any of these other factors. You can try them again and see if anything works. If it doesn't work, then maybe you need to try something else. What shall we try? Maybe we should try the half. You think it's going to work? What's half of this? Maybe 1/2 will work. Let's try it. Synthetic division. 1/2 of this. Okay, I'm just going to try it. Okay, and see if positive half is going to work. If it works, then great. So let's try half. So you have 1/2. We want to do the synthetic division of this, so we can want to see if it's going to work and give us a remainder of 0. So let's put this here. This is going to be 2, -9, and 4. So you drop this down. 2 times half is 1. This is -8. -8 times half is -4. Ooh, it worked. That's it. So it tells us that half is, this half works. So x equals half also is a factor. X equals 1/2, which simply means if you cross multiply, you have 2x equals 1, and 2x minus 1 is also a factor. So we have two factors. We have 2x minus 1, and we have x plus 1. So there's only one thing left. It's just to find the final factor. Since we know that this is a factor, we can actually factor this into 2x minus 1, and then the other one will be whatever we want it to be. But you can factor as this. I did this so you can understand that you can actually use a fraction if it works. Okay? So, but I'm going to erase this and just factor this using my knowledge of quadratic functions. So, what two numbers will you multiply to get 8? Because you multiply this by this, it's going to give you 8. If you get 8, what two numbers will you multiply to get 8? And then when you subtract, when you add them together, you get -9. The two numbers are -8 and -1. And so we're going to break that down. And this is going to be equal to 2x squared minus 8x minus x plus 4. This is going to be 2x into x minus 4 minus x minus 4. So you have 2x minus 1, x minus 4. You see this 2x minus 1 is what we got here. Okay, so this is what we were looking for, x minus 4. So the entire factors of this polynomial are x plus 1, 2x minus 1, and x minus 4. So that's how that works. So let us write our answer. I'm going to erase this. Now that I know what all the factors are. So we have 2x squared, 2x cubed, minus 7x squared minus 5x plus 4 will be equal to x plus 1, x minus 4, and 2x minus 1. That's it. That's the breakdown of this. And if someone says you should plot the graph after you've done this, one thing you know is that the graph must cross the x-axis, the y-axis rather, the x-axis at the point x equals -1. So this is one of the points where your graph will cross. See? That's just it. So when you plot your graph, you know which way it will go. Okay? It will also cross the x-axis at the point where x equals 4, because if you equate this to 0, you're going to get x is 4. That's where the function will be 0, and to be somewhere here. And it will also cross it at the point where x is equal to 1/2, which will be here. So your graph may be something like this. sorry, smooth. It might be something like this. It might be something, well, because this is a, yeah, it might be something like this. Okay, so it depends on what you're doing. And just understand that this knowledge, or it might be like this, beginning to forget my sketching of graphs, whichever direction comes first. Well, that's not important. Okay, so thank you for watching this video. I do appreciate your time and your love. Please make sure you share this video, you click the like button, and you hit the notification bell so you can see the next time I upload my next video. Once again, my name is Newton Okewoye. Never stop learning, because those who stop learning have stopped living. Have a wonderful time.